Welcome to another episode of Mr. Chow Time Pre-Algebra class. Is this the right lesson? No. Well, it is, but I've misnamed it. This should be called Solving Inequalities, Lesson 12, on page 367 if you're following along in the book. So, here's the idea. If you have an equation like 1 plus 2 equals 3, then you can do things to either side of the equation and it would still be true, right? So you could like plus 10 if you do it on both sides, right? So this becomes 1 plus 2 plus 10 equals 3 plus 10. And indeed, that is still correct. So you can still do that with addition and subtraction and inequalities. So if 1 plus 2 is less than 5, then if you add 10 to both sides, 1 plus 2 plus 10 is still going to be less than 5 plus 10. Okay? Okay. So here's an example. If I have x plus 5 is greater than 12 and I want to solve for x, how can I do that? Well, I can subtract 5 as long as I do it on both sides. Then I have x is greater than 7. And then, if I want to check my solution, I can just pick a number bigger than 7, like 10, and I can plug that into x. So 10 plus 5 is greater than 12. And yes, it is. It is bigger than 12. Yeah, so your turn. So we could subtract 10 on both sides, and y is less than negative 7. Then we can just take a number that's even smaller than negative 7, like negative 10, and we could write negative 10 plus 10 is less than 3, and yeah, 0 is less than 3. It works. Okay, one more, your turn. No, this is a different one. Okay, minus 7, x is greater than or equal to 3. So we can pick a number like, 13. 13 is bigger than 3. 13 plus 7 is greater than or equal to 10. Yeah, 20 is greater than or equal to 10. Okay. Am I talking too quietly? Sometimes I feel like I get a little bit quiet. But I think you can still hear me because this microphone is pretty good. Okay. Solve. 3 is less than b minus 1/3. Graph the solution on a number line. So here we would want to add 1 1/3 to both sides. Oops, 1 1/3. So that would be 4 1/3 is less than or equal to b. And then we would graph it. So 4 1/3 would be around right here. I'm going to switch colors. We wanted to fill in that and then go this way. And then, yeah, let's just stop there. Okay, with multiplication and division, you can still do it as long as it's positive. So let's take an example then. Let's say that Lenta is making each of her 7 friends a bracelet. And so the bracelet's going to have these charms, right? These things are called charms. And then she needs the wire, right? This thing right here. She needs the wire. And so the wire is $60. And she doesn't want to spend more than $450 on the bracelets for the 7 people. So find the maximum cost of each bracelet. Well, first we need to find the cost of charms per bracelet, and we'll just call that C. So there's going to be 7 people. Each person is going to get some charms. That's going to cost some money. Plus, she already spent $60. And she does not want to spend more. She wants this amount on this side. This is the total cost, right? She wants to be less than. She does not want to spend more than $450. So she can spend $450. So we can put an equal here. 450. So we'll subtract 60 from both sides. And that'll give us 390 and 7c. And we can divide by 7 because that's what we said earlier here, right? Multiplication and division as long as they're both positive. And yes, 7 is positive. So c is going to be less than or equal to whatever this is, right? What is this going to be? It's going to be something. It's going to be something good. So what is that again? 5 again. And this is going to be 7. So we'll just stop there. We don't need to go any further. $55.7. And because Taiwanese dollars cannot be in decimals, she can't spend 56, right? She needs to spend 55. So she can find the maximum cost of each bracelet. She can spend $55 on each bracelet. Yeah, because C is the cost of charms. That's the cost of charms. Find the maximum cost of each bracelet. I guess we'll have to divide the 60 by 7 also. No, I meant to write this differently. I meant to say, write the maximum cost of charms for each bracelet. My bad. All right, well, let's move on. $55 for the charms on each bracelet. Okay, your turn. Vanessa prepared 28 bags of popcorn to sell at a school fundraiser. She also received a $10 donation. Write and solve an inequality to find the price she should charge for each bag of granola popcorn. Oh my goodness. Was I falling asleep when I was writing this? Popcorn. She would never sell granola. Popcorn. If she wants to raise at least $115. So we could say P is the cost per bag of popcorn. And so she has 28 of those. Plus she already got $10. And she wants at least 115. So she wants to make more than or equal to. It's okay if it's equal to because it's at least. That would be 115. Okay. So subtract 10 from both sides. And that would be 105 is like this. And then divide by 28. Can you still see? Yep. Okay. So 105, that's going to be 3 something, right? 105, 28, 3. 60, 70, 84. 84, 9, 29. What is this? No, that's a 1. That's a 1. Yes, $21 or 21 remainder. So again, we don't need to go any further than this, right? They need to be well, they need to sell for a minimum of $4, right? Because if it's $3, it's not going to be quite enough. So minimum of $4. because this is going to be 3 point something. So if we round down to 3, she's not going to make enough money. So it needs to be rounded up to 4. $4 per bag of popcorn. You can do it, Vanessa. $4 per bag of popcorn, unless they're really tiny bags. All right, but what if it's negative? What if you're multiplying or dividing by a negative number? Then the inequality symbol must be reversed. You have to flip it. Flip it. So for example, 2 is less than 4. Yes, that is true. 2 is over here and 4 is over here. Look at that. It's less than, right? So what if I multiply negative 2 on both sides? Multiply by negative 2. Then over here, we get negative 4. And over here, we get negative 8. And which one's smaller? Negative 4 or negative 8? Negative 8 is smaller, right? So look at that. Look at that. The sign flips around. Isn't that crazy? So let's solve the inequality, then graph the solution on the number line. Let's do the first one in this this funny orange color, this burnt orange color. Kind of a pumpkin-y fall color, the color of leaves changing. Okay, so if we want to divide this by negative 5, then this on this side we'd have just x, right? And then on this side, we would have 9, negative 9. And then this sign here would get flipped. Flipia. And then we're going to graph. Okay, so this one is going to be, negative 9 is like way off my number line. I should have thought about this a little bit better. 6, 7, 8, 9, negative 9. And so this is going to be an open circle. And then we're just going to extend it this way. Just like that. Look how straight that line is. You guys proud of me? Let's do the next one in this purplish color. So first we want to add 2 to both sides, and then we get good old 6, negative 6, and then over here we have b over negative 8. So we're going to multiply by negative 8 on both sides, and these will cross out. Negative 8. And b is going to be greater than or equal to, what does that make it? Positive 48? Is that right? My math is horrible. 6 times 6 is 36. 6 times 7 is 42. 48. Yes. Oh, this is all way off the number line. Okay, so I guess 48, we'll just say is over here. 48, and then we'll just make a solid circle, and then b is bigger than it, so it continues going in this direction. Okay. Your turn. So here we have negative y over 4 is less than 3. So we're going to multiply both sides by 4 to get negative y is less than 12. Then we have to multiply by negative 1 to get rid of that negative sign, right? Because this is negative y, which is basically negative 1. You can imagine. So those cross out, and this becomes y is greater than negative 12. Last, your turn. Here we can just divide by negative 2, and that would give us negative 7 over 2 is greater than or equal to f. Well done. Here's your must do.